MS9. Describe or predict changes in mass of systems undergoing physical and or chemical changes. Wasn't this a fun question? So one thing I need to clarify right up front is that there are two jars in this problem. In table 2 it talks about mass of this some jar before and after you do all these things. And I just want to clarify that these numbers are from what I'll call jar A. These numbers are from jar B. So that should help quite a few people. I gave a lot of working with supports on this question because I knew people just didn't understand what this data table was actually telling us. And so really what you're looking at here is having jar A, and it tells us jar A has a bunch of sugar in it. So I could draw some grains of sugar, jar A. And then jar B, it tells us before and after something happens. So jar B I have here, and I know it has water in it. And then afterwards it has, sorry for the sloppy drawing, water, the jar, and sugar in it. So what you have to do is figure out first how much sugar was added from this jar into jar B, and then work backwards to figure out the original mass of jar B with just the water and no sugar added to it. Hopefully that helps clarify some of the confusion on this question. And the law of conservation of mass has to do with whether or not mass can change when physical and or chemical changes happen. We talked about this in the last unit as applying to open or closed systems with a chemical change, but keep in mind that no matter what, when you're dissolving, you're not really causing any gas to escape, which is usually when the mass changes. So explain to me, why is it that you can use this math to figure out how much this originally had a mass of?